All right, so exiting out of presentation mode now so I can jump into MakerChip. Um, so I'm going to introduce you now to the shell that we're providing for your development of the RISC-V CPU. So once again, open up the GitHub repository for the workshop. Hopefully you've already got that up or at least saved a link to it. And scrolling down here, similar to the starting point for the calculator, there's some starting point code for the RISC-V design. So again, based on your birthday. So this is opening up in MakerChip some starting point code for your RISC-V work. And I'll just give you a second to get that open yourselves. So just walking through what's in this shell. So this is including some content that's used by the shell, some macro definitions and whatnot. As you see in all MakerChip sandboxes, the instantiation of the MakerChip module interface. And the first thing in here of any substance is a program that should look pretty familiar to you. So the shell is providing a RISC-V assembler. Right? So this is using standard infrastructure for TL Verilog. Some of the more advanced functionality and capabilities that TL Verilog enables are unlocked through a macro preprocessor called M4. And we're using that macro preprocessing to define a RISC-V assembler. So this assembler is not 100% compliant with the syntax that's defined for RISC-V, but it's close enough that in most cases you can probably figure out the syntax that you need to express. We're not going to do much coding of programs in the assembler here, but it is providing you the test program that you guys wrote with Kunal using the RISC-V tools to assemble your code, to compile your code from C++ and generate some assembly code. So this code matches as closely as we were able the code that you were generating from your compiler. So it should look pretty familiar if you look through that, summing up numbers from 1 to 9 actually. And so we're providing for you a CPU pipeline and giving you a reset signal hooked up to the module interface in stage 0. And then you can insert your code here. The shell might not look 100% like what I'm presenting in the video. We may make some edits and improvements to it by the time you're doing the exercises, but I think it'll look pretty similar to this. Down here at the bottom, well, first of all, so passed and failed, as you've seen before, communicating with the platform when we passed, and this is just initialized to just tell the platform that we passed after 40 cycles, resulting in the passed message in the log, of course. And then some macro instantiations. So we're providing for you in the shell a few components. And jumping back to the presentation, sorry, back here. Essentially, we're providing for you all of the array structures. So the instruction memory, pre-populated with the program that you're defining through your assembly instructions. Right, so all the assembly code that's written here for this test program is pre-populated in the instruction memory. So when we comment out this line, as you'll be walked through in the labs, and compile, Control Enter to compile, we get a diagram that shows us that we have an instruction memory that contains instructions. And what did I want to say? I lost my train of thought. Okay. And in addition to the instruction memory, we're also providing the register file and the data memory. So register file, read and write, and data memory when we do eventually get to that. So these are, standard array structures. Generally, you would include a generic library of components and instantiate these as array elements just through macro instantiation. The ones that you're going to use here are customized for the lab, but they're basically generic. And the last thing here is an instantiation of visualization for the CPU. So similar to the visualization for the calculator, but a little bit more advanced. And I'll show you that visualization now. And I'm going to show you that in instead of using the shell, using the reference solutions. So under help, as I mentioned for the calculator example, if you get stuck with the RISC-V example and can't figure out how to get past it, you can refer to the reference solutions to help with syntax and help understand the design that you should be implementing. So I'm going to, again, open that up.